Good morning, students. Welcome to online video class. This is 9th standard chemistry, unit 12, periodic classification of element lesson. Let's move on. Introduction. We live in the world most of the substance with great diversity. Substances are formed by the combination of various elements. All the elements are unique in their nature and properties. To categorize these elements according to their properties, scientists started to look at for the way. In 80s, there are only 31 elements are known. After 80s, in 1865, the number of elements become 63. Now, 118 elements have been discovered. As different elements were being discovered, scientists gather more and more information about the properties of these elements. Now how many elements present? 118 elements. 118 elements present. They found it difficult to organize all that was known about these elements. They started looking for some pattern in their properties, on the basis of which they would study such a large number of elements, which case. In this lesson, let us discuss concept of classification of elements proposed by various scientists from early to modern periods. Let's see early concept of classification of elements. The first classification in 1817, John Dobereiner, German scientist, suggested two methods grouping elements based on their relative atomic mass. This is the first classification. Dobereiner triads. He arranged the elements into groups containing 3 elements each. He called this group as triads. How many elements arranged? 3 elements arranged. So he called these groups as triads. Tri means 3. Dobereiner showed that when the 3 elements in a triad are arranged in ascending order of their atomic masses, the atomic mass of the middle element is nearly same as the average atomic mass of the other two elements. The first and last elements are taking arithmetic mean, and the mean value is same as to middle of the element atomic mass. This is Dobereiner law of triads. The scientist Dobereiner arranged in 3 layer, that means triads, arranged in 3 elements in the periods. 3 elements present in the groups. The first and last elements atomic mass of the arithmetic mean value is same to middle of the element. This is Dobereiner law of triads. Example, in triad group 1, arithmetic mean of the atomic mass of first and third element so the atomic mass of sodium, see this tabular column, first and last, first group, triad first group, first and last, lithium is first element, sodium second element, potassium third element. First and last element taking arithmetic mean 6.1 plus 39.1 divided by 2, we get 23. So the 23 is which atomic mass? Sodium atomic mass. So taking arithmetic mean of first and last element, we get middle of the arithmetic mean. The middle arithmetic mean value equal to middle of the element atomic mass. So this is triad. Another example, group 2, calcium, chlorine, bromine, iodine. Chlorine, iodine arithmetic value equal to bromine value. The third group, calcium, strontium, barium. Calcium and barium arithmetic value equal to strontium. This is Robenier law of triads. Let's see limitation of limitation of Robenier triads. The first one, Robenier would identify only three triads from the elements known at the time, and all the elements would not be classified in the form of triads. The remaining elements are not able to classify in triads. This is first limitation. The second limitation, the law was not applicable to elements having very low and very high atomic mass. Law not applicable to very high and low atomic mass. These are the two limitations of Robenier triads. Let's learn about another early concept of classification of element. Second one is Newland's law of actives. Newland law of actives. In 1866, John Newland arranged 56 known elements in the increasing order of their atomic mass. He observed that every eighth element had properties similar to those of the first element. Like the eighth node of the octave of music is similar to first. This arrangement was known as law of octaves. The law of octave Indian music system is sa, re, ga, ma, pa, da, ni, sa. The first and last note are same. So the first and last note of these octaves are same, that is sa. S-A. Likewise, in this Newland table of octaves, the element fluorine is 18th from the element hydrogen. They have similar properties. The first and last elements are similar properties. So in Newland arranged in eight elements. The first and last elements are having same properties. This is Newland table of octaves. Newland arranged in 8 elements. The first element and last elements are having same properties. Let's see limitation of Newland law of octave. What is act? Act means 8. This scientist arranged in how many elements? 8 elements. 8 elements are arranged in similar group. The first and last elements are same physical property, same properties. Let's see limitation of Newland's law of octave. The first one, there are instead of two elements being fitted into same slot. Example, cobalt and nickel present in a same slot. This is first limitation. The second one, some elements totally dissimilar in their properties. Some elements totally dissimilar in their properties were fitted in the same group. Arrangement of copper, nickel, palladium, platinum and iron, iridium in the rows of halogens. These are the dissimilar properties present in a same group. This is another limitation. The third one, the law of octave was not valid for elements that had atomic mass of higher than calcium. Not this law of octave not suitable for atomic mass higher than calcium. The fourth one, Newland's table was restricted to only 56 elements and did did not leave any room for new elements. There is no vacant place present in this Newland law of active period. So this arrangement of elements restricted only for 56 elements. The last limitation, discovery of inert gas, that means noble gases, at later stage made the 19th elements similar to first one. Example, neon between fluorine and sodium. So later discovery of inert gases, there is no place in the Newland law of active. So 9th elements are similar in the first one. So first and 8th elements only already said similar properties. In after the discovery of inert gases, the first and 9th elements are also similar properties. Like example, neon between fluorine and sodium. These are the similar properties. Let's learn about another early concept of classification, Mendeleev periodic table. In 1869, Russian scientist Mendeleev observed that elements of similar properties repeat at regular intervals when the elements are arranged in the order of their atomic masses. Based on this, he proposed the law of periodicity, which states that the law of periodicity states that the physical and chemical properties of the elements, are the periodic function of their atomic masses. What is Mendeleev periodic table? The Mendeleev periodic table states that the physical and chemical properties of the elements are arranged in function of their atomic masses. He arranged 56 elements known at the time according to his law of periodicity. This was best known at the short form of periodic table. See this periodic table. This is Mendeleev periodic table. This periodic table arranged in function of their atomic mass. This periodic table contains two subdivisions. One is A, another one is B. 7 periods, 8 groups present in this Mendeleev periodic table. The periodic table contains subdivision. Let's see features of Mendeleev periodic table. First features, it has 8 vertical column. The vertical columns are called groups. The Mendeleev periodic contains 8 vertical columns. These 8 vertical columns are called groups. 7 horizontal rows are present. These horizontal rows are called as period. What is group? Vertical columns. 8 vertical columns are called group. 7 horizontal rows are called periods. The second one, each group have 2 subgroups. That is A and B. All these elements appearing in this group were found to be similar properties. For the first time, the elements were comprehensively classified in such a way that elements of the similar properties were placed in the same group. The similar properties having elements are placed in the same group. He not noticed that certain elements would not be placed in their proper groups in this manner. The reason for this way, the wrongly determined atomic masses. Consequently, those wrong atomic masses were corrected. Example, atomic mass of beryllium was known to be 14. Mendeleev, it is corrected by 9. So now the beryllium atomic number is 9. So placed in the proper place in the periodic table. Let's see limitation of Mendeleev periodic table. The first one, elements which large difference in properties were included in the same group. Large different physical properties are present in the same group. For example, hard metal like copper, copper and silver were included along with soft metal like sodium and potassium. Copper and silver are hard metals. Sodium and potassium are soft metals. These elements are present in same group. This is first limitation. So large difference present in these elements. Second one, there is no proper position would be given to the hydrogen element. So there is no proper position present in periodic table for what element? Hydrogen element. Non-metallic hydrogen are placed along with their metals like lithium, sodium and potassium. These are the non-metals, sodium and potassium. So these are present in a same place. Same non-metallic hydrogen was placed with the metals like lithium, sodium and potassium. Third one, the increasing order of the atomic masses. Increasing order of the atomic masses was not strictly followed throughout. What is Mendeleev periodic law? The periodic law, function of their atomic masses only. The elements are arranged in function of their atomic mass. So this atomic mass, the increasing order of atomic mass is not followed by strictly throughout the periods. Example, cobalt and nickel and tellurium and iodine. These are present in same group, same column. Last one, no place for isotopes in periodic table. There is no place present in periodic table. Already you know what is isotopes. Same atom having, same element having same atomic number, different mass number. These elements are called isotopes. These isotopes are, there is no place for isotopes in periodic table. These are the limitation of Mendeleev periodic table. Mendeleev periodic table. See this periodic table. This is modern periodic table. This modern periodic contains 7 periods, 18 groups. 7 periods and 18 groups. This 18, the modern periodic table state that the physical and chemical properties of their element function of their atomic number. But Mendeleev periodic table, the elements are arranged in atomic mass, but modern periodic table arranged in atomic number, increasing order of their atomic number. Let's see metals, non-metals and metallites. What is metals? Metals are typically hard, shiny, malleable and fusible, ductile with good electrical and thermal conductivity. Metal have hard in nature, also shiny appearance and malleable. What is malleable? The malleable means the metal can be made as sheet. It is converted into sheet. It is a fusible nature and also ductile. What is ductile? It can be drawn into wire. The metal can be changed into wire. These metals are good electrical and thermal conductivity nature. Except mercury. Most of the metals are solid at room temperature. Most of the metals are solid in nature except mercury. These are mercury present in a liquid state. Metals occupy large area in periodic table. See this periodic table. Most of the elements are metal. So metals are present in large area in periodic table. This periodic table category as follows. First one, alkali metals. Lithium to francium. Top to bottom present in first group elements are called alkali metals. Second one, alkaline earth metals. Example, beryllium to radium. Top to bottom. And transition metals. Group 3 to group 12 elements are called transition metals. The fourth one, p black elements. So example, aluminium, gallium, indium, tellurium, tin, lead and bismuth. These are the p black elements. So most of the elements are metals in periodic table. These metals are classified into 4 ways. First one alkali metals, second one alkali earth metals, third one transition metals, fourth one p black metals. These are the metals. Let's see non-metals. What is non-metals? The non-metal is elements that does not have the characters like hardness, shiny, malleable, and ductility. So not having these properties. What are the properties? There is no hardness, there is no shiny, there is no malleable, there is no ductility. In other words, the non-metal is the element does not have the properties of metals. Does not have the properties of metals. All non-metals are arranged in p block only. All non-metals are arranged in p block only. For example, carbon, nitrogen, oxygen, phosphorus, sulfur, selenium. These are the non-metals. Also halogen families and inert gases. These are non-metals. Most of the non-metals are arranged in which black elements? P black elements. P black elements. Let's see. Another one is non-metalloids. What is metalloids? Elements which have the properties of both metal and non-metals are called as metalloids. Elements which have contains two properties. What are the properties? Metal properties, also metalloid properties. These elements are called metalloids. For example, boron and arsenic. Boron and arsenic are example of metalloids. Dear children, these are the metals, non-metal and metalloids. Learn today's topics. Note the assignment question. First question. What is metalloids? Second question. State law of periodicity. Law of periodicity. Third question. State Dobereiner law of triads. Learn these questions and write the assignment question for your classwork note. Thank you, students.